What if you could hire a worker that never calls in sick, never takes a vacation, and operates around the clock for less than $6 an hour? That's not a fantasy. That's the math behind humanoid robots entering the workforce right now. But the sticker price only tells part of the story. Today, we're breaking down the real cost of humanoid robot workers, from the price tags no one talks about to the hidden expenses that could make or break your investment. Let's start with the numbers that matter. In 2026, the humanoid robot market has split into 4 clear pricing tiers, and the range is wider than most people expect. At the bottom, you have entry-level machines like the Unitree R1, priced at just $5,900. This is a compact, education-focused humanoid designed for research labs and classrooms. It walks, it moves, but it's not replacing anyone on a factory floor. Think of it as a learning tool, a way for universities and startups to experiment with humanoid technology without betting the budget. Step up to the mid-range consumer tier, and you're looking at $16,000 to $50,000. The Unitree G1 sits here at around $16,000, a compact humanoid standing about 4 feet tall, capable of walking at 4.5 miles per hour and carrying roughly 7 pounds. BYD has also entered this space with its solar-powered Boyobo D, targeting a launch price around $10,000 for basic household tasks like cleaning and laundry. And then there's Tesla's Optimus, targeting $20,000 to $30,000 at full production scale, though early units are shipping closer to $40,000 to $50,000. Tesla is betting that automotive-style mass production will crush the price curve the same way it did with electric vehicles. The industrial tier is where things get serious. Figure's humanoid platform falls somewhere between $30,000 and $150,000, depending on the deployment. Agility Robotics Digit comes in around $250,000 for pilot programs, designed for warehouse logistics with a 35-pound payload capacity. And Fourier Intelligence's GR1 targets the $150,000 to $170,000 range, built for both industrial and healthcare markets. At the top sits the Boston Dynamics Atlas Electric at $420,000, a premium enterprise-grade machine unveiled at CES 2026 for the most demanding industrial applications. This is the robot you deploy when the task is too dangerous, too precise, or too physically punishing for a human crew. The average price across all commercially available humanoid robots right now sits at roughly $120,000. But that number is dropping fast, and the trend line points in only one direction. Here's where most analyses get it wrong. They quote the purchase price and stop. But industry data shows hidden costs can add 50 to 100% on top of what you paid for the robot itself. And if you don't plan for them, they will wreck your return on investment. First, there's integration. You need to configure the robot for your specific environment, programming task routines, calibrating sensors for your facility's layout and lighting, and connecting to your existing automation infrastructure. For industrial deployments, integration alone can run tens of thousands of dollars. Some companies report spending nearly as much on integration as they did on the robot. Then there's safety certification. A new ISO standard, 257851, published in May 2025, specifically addresses industrial mobile robots with actively controlled stability. That's the official term for bipedal humanoids that collapse when powered down. Compliance means safety audits, restricted zones, emergency protocols, and potentially redesigning parts of your workspace. Ignoring this step isn't an option, it's a legal and liability requirement. Infrastructure is another hidden cost. Many humanoid robots in 2026 run on batteries with limited life. Some facilities are now deploying hot swap battery systems where robots exchange depleted packs for fresh ones in under 2 minutes. But building that infrastructure isn't free. You need charging stations, battery inventory, maintenance scheduling, and electrical upgrades. For larger fleets, this can become a significant capital project on its own. Training your existing workforce matters too. Someone needs to supervise these machines, troubleshoot failures, and manage the human-robot workflow. That means retraining employees, creating new roles like robot fleet supervisors, and managing the organizational change that comes with deploying machines alongside humans. The human side of the equation is often the most underestimated cost of all, Add software licensing, ongoing AI updates, insurance, which now includes specialized robotics liability premiums, and annual maintenance, and you start to see why the total cost of ownership is significantly higher than the catalog price. Now let's run the math that companies are actually running behind closed doors. Take a fully loaded human worker in manufacturing: salary, benefits, insurance, payroll taxes, overtime. In the United States, that comes to roughly $35 per hour. A skilled worker in Germany earns a similar rate, and those costs go up every single year. Now consider a humanoid robot purchased for $100,000. Spread that over an 8-year lifespan, and your capital cost is about $12,500 per year, or roughly $6 per working hour assuming double shifts. Add energy costs. A humanoid doing light physical work consumes far less than a human worker's caloric equivalent in electricity. Factor in maintenance, software licensing, and the occasional repair, and analysts estimate the all-in hourly operating cost lands somewhere between $10 and $14. That means a humanoid robot can operate at roughly a third to half the cost of a human worker per hour. And unlike human employees, it doesn't need health insurance, retirement contributions, or overtime pay. It doesn't get fatigued on the night shift. It doesn't file workers' compensation claims. And it can be redeployed to a completely different task with a software update. The real-world data backs this up. Figure's Aero 2 robot was deployed at BMW's Spartanburg plant for 11 months. Over that time, it logged more than 1,250 hours of operation, loaded over 90,000 parts, and contributed to the production of more than 30,000 vehicles. At an estimated robot cost of $100,000, the single-position payback period came out to approximately 2 to 2.5 years. BMW has already begun exploring expanded deployments based on those results. Industry projections from UB Tech and Bank of America forecast that average humanoid prices will drop from around $35,000 in 2025 to roughly $17,000 by 2030, a decline of 40 to 51%. As prices fall, that payback window shrinks dramatically. What takes 2 years to recoup today could take less than 1 by the end of the decade. So who's actually buying these robots? According to Counterpoint Research, global humanoid robot installations hit an estimated 16,000 units in 2025. That number is expected to blow past 100,000 cumulative units by 2027. We're watching an exponential adoption curve in its earliest stages. The market is heavily concentrated right now. Shanghai-based Agibot leads with about 31% of global installations, having deployed more than 5,000 units across hospitality, entertainment, manufacturing, and logistics. Unitree holds second place at 27%. UB Tech and Leju Robotics each capture roughly 5%. China is dominating the early market. The country recorded over 610 robotics investment deals in the first 9 months of 2025 alone, totaling about $7 billion, a 250% increase year over year. The Chinese government is backing this aggressively, leveraging its existing electronics supply chain and manufacturing infrastructure to outpace the rest of the world. But the West is scaling up. Tesla announced in early 2026 that it's converting its Fremont factory, previously used for Model S and X production, to manufacture Optimus humanoid robots, with production scaling toward tens of thousands of units by the end of 2026. Figure AI raised over $750 million in Series B funding backed by Microsoft, Nvidia, and Jeff Bezos. Agility Robotics has built a dedicated factory capable of producing 10,000 digit robots annually. The biggest shift is the emergence of robot-as-a-service models. The 1X Neo, for example, is available at $499 per month on subscription. No massive upfront capital required. This model is gaining traction, especially in China, where companies offer humanoids for rental and retail, live performances, and promotional events. For smaller businesses, this changes everything. You no longer need 6 figures to get a humanoid on your floor. The industry's leading adoption are logistics, manufacturing, and automotive, projected to represent about 72% of all humanoid installations by 2027. So what's the takeaway here? The real price of humanoid robot workers is not just the machine. It's the integration, the infrastructure, the training, the maintenance, and the organizational change required to deploy them effectively. But the economics are reaching a tipping point. With payback periods dropping below 3 years for the right applications, prices projected to fall another 40 to 50% by 2030, and robot-as-a-service models eliminating upfront capital barriers. The question is shifting from can we afford robots to can we afford to wait? Early adopters gain something no amount of money can buy later: experience. 4 years of operational data, optimized workflows, and institutional knowledge about human-robot collaboration. That competitive advantage compounds over time, and latecomers will spend years trying to close the gap. The revolution isn't arriving with a single headline robot. It's arriving with a slow, competitive spread of machines into the physically demanding, dangerous, and repetitive corners of work, and eventually into our homes. The robots are ready. The economics work. The only question left is execution. If this breakdown changed how you think about the future of work, hit that subscribe button and drop a comment. Which humanoid robot do you think will dominate by 2030? We publish deep dives like this every week. See you in the next one.